can do that just based on non-proprietary synthetic data that we produce, meaning non-proprietary to a customer. And so the goal is get Archie hired as an entry-level engineer, right?
Yeah.
Get him in the door. We then have a relationship with the customer. We have a data sharing agreement, right? And all of those things sorted. And then Archie can start learning on the things behind the firewall.
Yep.
Right? Obviously subject to the customer's acquiescence, right? But we can then ingest their PLM system. We can ingest all of their model-based tools and models. We can ingest a lot of the real-world performance of that system, quality escapes, right? There is a bunch of stuff there. And so we think that Archie can move up the expertise scale fairly rapidly from entry level to kind of average to expert engineer on the basis of a lot of that real world data. And of course, improvements in the AI models as well.
And do you have a definition when you talk about engineering AGI? We haven't found sort of a generally agreed upon definition of AGI. What's your definition of AGI and how does it fit into the test of someday when you have an engineering AGI, how will you know you have it?
Yeah, so back to the evals, we have adopted what's called Bloom's taxonomy, which is a cognitive knowledge taxonomy for human learning, developed in the 50s and has been applied to LLMs in recent years. We have adapted it kind of to the engineering task, and so the taxonomy has kind of a pyramid, right? At the lowest level, you have just recall of information, right? That's relatively straightforward. Then you have semantic understanding of the design. So in addition to recall, like what does this part do? Then you have the ability to evaluate a design or a change to a design, right? So what is the performance impact of changing this component, for instance, or resizing something? Then there is the ability to find mistakes in a design, right? So this is the error correction and infilling. Then to synthesize a brand new design or a significant change to an existing design. And then kind of the pinnacle, which we call EAGI, Engineering AGI, is reflection, which is some degree of self-awareness of what process did I just use to do the preceding 5 levels in this hierarchy. What process did I use? What are the limitations of that process? Is there an alternative process? Where could I have gone wrong? These are the kinds of things that actually most engineers in the field don't do very well, and is reserved for kind of the senior levels, the experts or the technical fellows, right, in large industrial companies. And so to us, that is certainly the pinnacle of human engineering intelligence, is the self-awareness of and your own limitations of the engineering process. And then there is a different dimension, which is, can it generalize across domains without us having to train it on the domain? So I would say those are the 2 axes, and you could argue that you can accomplish sort of AGI on one axis, AGI on the other axis, or AGI on both axes. Pick your poison. We hope to do both.
What do you think it's going to